Hey, Mayank. Can you hear me?
Hello. Hi.
Hi. It looks like it's going to be you and I because
hmm
Steve said he can't join. And I think um, the other guy, I forget his, so people aren't joining either. So probably going to
Yeah,
be a
it's
short
it's
meeting.
the end of the year, so people might be busy with their own uh end of the year performance reviews and stuff. Oh,
Yeah, I
Bananas
mean,
has joined.
also,
Raquel.
Michael showed up. Good. And we don't have, we have
Hey guys.
tax season in the US too. So, hey, Rachel. You still there, man? Rachel?
Yep.
Okay. Yeah, I was just saying Steve said he couldn't be here this
Joining.
week.
Oh, yeah.
We weren't there last week, I think.
Yeah.
But Benito said he's probably busy, so he might only catch up by recording over the next several weeks. Anyway, I don't know whether you've been following this discussion, Rachel,
I
but
checked out the recordings. Yeah.
okay. But one of the things that Steve said last week, and which is kind of the thing that I was um, working on, was he pointed out that um, because the expert consensus value changes within the same spectrogram or the same EEG ID,
Right.
he thought he had better. He's only working with EEGs. He doesn't do much with the spectrogram, meaning the spectrograms converted from the EEG, I should say. But make a long story short, the interesting thing was he said that when he captured the
Change in consensus.
changes,
Right. Yeah.
right, change in expert consensus, and then sliced the EEGs accordingly, then he got a better score than if he were to just group by EEG ID.
Right.
That's so I started to do that with pandas, but just so you guys know, it's it's an interesting challenge which I found out by luck and some probing as to what the specific issues or challenges. First of all, have either of you tried that or?
No, I haven't.
Okay. So one of the things, just a heads up to kind of make it maybe as and when you get to that part, just to give you a heads up that that's going to be somewhat of a challenge. And in fact, I was using your technique of posting or posing the question to ChatGPT and having it generate the code after I struggled for a while. And I was like, man, this is complicated. But let me share with you guys why this thing is a little more complicated than I originally thought. So, and while I pull it up, see, one would think that the easy way to generate the data for such EEGs is just to group the first group by EEG and then group by expert consensus, right?
Yeah,
and then get the max values.
Yeah.
Correct?
Yeah, max min. Yeah, absolutely right.
Right. If you get the max, then you can subtract to find the middle and then appropriately find the slice. Right. Are you with me so far as to what I'm?
So
the approach I'm talking about?
So you're grouping finally on consensus also, right? So like, does that make a difference of max or min? Like, I didn't understand what was the middle that you were saying?
Okay, so here is this scenario, right? Like you can have, let's give a simple example. You can have seizure,
Right.
and let's say the first 3 slices at 0, 20, and 0, 10, and 20 are seizure expert
Okay.
consensus.
Right.
And then at 30 and 40, let's say it changes to LPD,
Okay.
just to take an example.
Right.
So now what you ideally want is, so 0, 20, and 30 EEG offsets are seizure.
Right.
So, now what you then, or at least what I intended to do then, is to take a 50-second slice, but which is centered on the offset 30, right? Because
Middle of what you have. Right.
what's
Okay.
actually happening is you go from 0 to 30. The 30 is the last offset start.
Right.
And from that, you get a 50-second, right? Which is, so
Right.
your length of seizure
So
is from 0
what
to
is
80
30 here, Steve? Sorry,
30 is,
Srinivasan?
the 30 is the
Last.
start of the EEG offset, last EEG offset for
Oh, last
seizure,
EEG offset. Yeah.
right? For the seizure. I'm just making up an example, by the way, right? So that 30 plus 50 seconds, up to 80 seconds, you have, right?
The first
So
one, yeah.
when the last seizure offset is at 30, that means that the EEG for 50 seconds starting at 30 and ending at 80 is still seizure. But what that means is the expert consensus label is seizure for the EEG starting at 0 and ending at 80. And you want the center chunk from that. You want the center 50-second chunk from that.
Right.
Right? So that means you can drop 30. So that's why I'm starting off with picking the 30, which is the max offset of that group.
Okay.
When I group by EEG and then group by expert consensus and then take the max, then I get the 30, right?
Okay. Yeah.
Right. So 30 plus 50 is 80. And then, from 80, I subtract whatever, I'll divide and then subtract. So I get the middle chunk of it.
Middle chunk.
Okay.
Right.
That's one. Then it switches to LPD for, actually, for, let's say 40 and 50. Right. Then I group by LPD, so then I get the 50, and I add another, meaning 50 is the max EEG offset for the LPD bunch, and then there'll be a 50-second EEG from there. So, I do the math to figure out the middle of that chunk and take that, right? But, so that's what I was thinking, but as it turns out, there's a kink in the data that kind of threw me for a loop. So you guys can see my screen, right? Okay. So look at this particular situation though. So, so I kind of tried it and I convert the expert consensus to...
I have one question before we get into that. Like, is there a reason why you're using, like, does expert consensus change in the same way where the 6 labels change? Or like, I'm guessing the expert consensus is kind of like a summary of the 6 labels, right?
Yes, I would imagine so. Correct. Yes.
But is that so? If the expert consensus is same for a particular EEG ID, does that always mean that the 6 labels are also the same? Or I thought for some reason those 6 labels does not necessarily the same. Like, for example, I'm saying, let us say expert consensus in simple words is just the max of the 6 labels counts. So the values on the 6 labels can change, but you'd still have the same expert consensus.
That's possible. You can have the distribution be slightly different. And I haven't checked whether that is the case. I haven't looked into that specific question, but it is as to whether remember that, we convert the votes actually turns out that it is, the raw data is just the count of votes in every category,
right?
Right. But
So,
we convert that to the probability because we want the answer in probability. Yeah. So it is possible that somebody, that the expert consensus category remains seizure, but the votes of some people move around between seizure to something else.
Okay. So because you guys, I think last call when I was listening to the recording, when you guys spoke about expert consensus change, I was directly thinking of whether you guys were actually looking for the change in votes from one row of the EEG to the next.
No. He's at least as far as I understand it, he just does the expert consensus column.
Okay.
Yeah, not so much the change because again, where it originates. So if you go back, where these things originally the idea I had, and I can see how Steve's idea is superior to mine, but the original idea I had was to, we have 106,800 rows, right? So and precisely to your point, every row, even if the expert consensus doesn't change, the votes could change, right? So what I was thinking is, why wouldn't you just use all of the data, that is, generate EEGs and generate spectrograms per row? So forget about this grouping by EEG or grouping by spectrogram or grouping by EEG. Just generate it for every row, because you can do that because there is a label ID which is given, which is unique to every row. Instead of using EEG ID or spectrogram ID, you can just use label ID, and there are 106,800 label ID. So I did that, but what I found when I ran the spectrogram with that approach was my scores were worse. Right.
It maybe because of the rows has too many data. So if you combine that row with others and you're trying to form a consensus of how they are being processed. So are you processing it by axis or by I mean to say, if you look at the axis here, the axis 0 or axis 1. So I was thinking by combining multiple rows, or you were just trying on a single row?
No. So at least what I did was every single row. That was just an extreme case to try out what my results are, because then I don't have to worry about taking the middle slice or anything. I just take a 50-second slice for every row in the entire data set and use that for my spectrogram. And in case of spectrogram, it's not 50 seconds, it's 600 seconds actually, or 10 minutes. But I take a 10-minute slice for every spectrogram for every row. So for every spectrogram, not grouped by spectrogram ID, I take the particular one. This kind of accounts for what Rakhil is saying, that, okay, even if your expert consensus remains the same, if your vote fraction moves around by something, then my approach would catch that, right? Because if the votes were to change depending on something that some doctors detect and others don't, then by training on all of that, then I'm sensitive to the vote fraction changing. Whereas any approach that relies on the expert consensus will not depend on that. It will be a consensus-driven thing. So even if the underlying vote proportion changes, the consensus is what drives the selection of the data in the approach that the approach that Steve took, that I think is superior, and I'll get to why.
Okay.
Right.
Nice.
So Rakhil's point is covered by is better addressed by my approach of taking every row, because if the underlying proportions change, then whenever you group, you lose that. But I haven't checked whether the underlying proportions change within a group. I have not looked into whether cases like that exist or not. If they exist, then if you do it row by row, then then that approach that I was doing row by row would be superior because it would be sensitive to the proportions changing. Whereas whenever you group, then you will lose that because you're grouping. Right? But Steve, and like I told you, at least on spectrogram, I got worse results. I did not have the chance to try it for EEG, and when I tried it to generate the EEG data, I ran out of space, at least on Kaggle. So, right, because it's huge, the data to be generated.
So you were not using the Chris Stewart's files there, the NPY files?
No, I was generating them myself.
Okay. Okay, so you ran out of 107 gigs of memory or 100 gig?
No,
107
it
gigs
isn't that big, but it isn't that big, but and again, when I was generating EEG, because I did successfully run it on spectrogram.
Okay.
But to make a long story short, the approach Steve had talked about last week was to not do what I was doing, which is every row, but kind of go in between, which is the approach I was talking about earlier. That is group by EEG ID, and then be sensitive to when the expert consensus changes. But if it doesn't change, then group them together. So thereby, you don't do it for every row, and you're only sensitive to the change in expert consensus, not so you treat everything else as a group, right? As a group of things. So therefore, you would not worry about getting 106,800 rows. You would get far less than that. And through the math I did and stuff, I figured out it's about 18,640 rows.
Okay.
But rather than 17,089 rows, which is what happens when you group purely by EEG ID. You get additional rows. The difference between 17,089 and 18,640 is 1,551. I spent a lot of time last week on it, which is why I'm able to rattle off these numbers off the top of my head. But that is the additional rows you get because of the fact that you're adding rows when the expert consensus changes. But if you just take an approach on pandas of grouping by expert consensus and then taking the values, right? So far, you guys are with me as to what the approach that Steve was kind of adopting, right? So, but just grouping and grouping again, grouping by EEG and then grouping by expert consensus, there's a problem though, which is look at what happens in the case of EEG ID 2137901, which is one of the EEG IDs. And I just, because I was playing around with it, I kind of stumbled on this particular one. And in this case, what ends up happening for that particular EEG ID is this is what happens. It starts off with other, okay? Actually, that's also not a, I want to show you guys an example of the full thing. I had the full, well, I find it. This, let's look at, okay, when the EEG ID is 2137971, here's how that shapes up. And you see the problem if you were to group by expert consensus that would happen is, and you take the math here. So let's just look at the raw data, right? The raw data, here's what happened. You get other up to 12 offset.
Right.
Then offset 30 to 48 is seizure. Right? Then there's a whole bunch of LPDs. And then
Right.
other shows up again at the end.
Okay.
This row screws up my entire strategy of grouping by expert consensus.
Oh, why? But
Can you see why?
no,
Huh?
I don't see why
Okay,
though.
because if I group and take the max, guess what happens? It will give me 158.
You would have to use time also, I guess, right? You would have to use some format where you can kind of use the order of time. Like
But I mean, basically, all I'm saying is that simple approach of
grouping.
by EG and then by
Okay.
expert
I see what you're
consensus
saying.
fails.
Right. Okay.
Because what
If
I
you
really
have
need from this
repeat, right? Okay, makes sense.
is I need to capture the 12. I
Mhm.
need with another title. I need to
Right.
capture 48 with seizure, and I need to capture 110 with LPD.
LP,
Right?
right? Yeah.
But and then I need to also capture other with 158.
Yeah. Makes sense. Yeah.
But that's not what my simplistic approach does.
Right. Will work.
It captures seizure 48, okay, LPD 110, okay, and then other 158. And by doing that, I lose this chunk.
Yeah.
So you miss out on the outliers here, the 158, the 110. You only get
No,
the
actually,
50.
I capture them. I don't get these.
Okay.
I mean, depending
okay.
on what you do. Because
So
if
you
you
are
take the
going
min,
for
then you will get these, but you will miss. So depending on which way you choose to go, or at least the simple approach didn't work. Let me put it this way, right? The simple approach I was thinking of didn't work. So you have to do something a little more complicated to capture all of them. Do you follow at least the problem that I'm highlighting?
Yeah. Actually, the first thing
So
that I was
this is what I
thinking
was
of was
struggling with.
successively subtracting the rows, right? Like if you do other minus other, other minus other, and then when it becomes seizure minus other, that's where the change is happening. And you have it sorted by time on offset. That was the approach I was thinking of. But yeah, it is more involved than just grouping by consensus. That makes sense now.
Yeah. That's what I wanted to highlight, you guys, because that would be my default approach until I figured out a case where it doesn't work.
Doesn't work. Yeah, makes sense.
So I'm now using this EG to test my approaches because this is a good indication of
yeah, makes sense. Okay.
Right, because that's what I was struggling with over the last week. I was just like beating my head against it, going, what the heck?
I still have some problems in understanding how are you able to capture this 158 seconds in the 50-second window.
No. So the way it works, Mayank, is you take. I mean, assume that we have the Panda score to code to capture you for this EGID. You will have 4 slices, or at least my goal is to have 4 slices. Okay, one slice. Again, starting with the raw data, one Now remember that there is a single EGID Parquet file. Okay, but so what I would do with that Parquet file is I would take that Parquet file. I would go up to 50 plus 12, which is 62 seconds, right? 50 seconds. Remember, always keep in mind that the EG label offset seconds is the starting point of the offset. And then if it is EGs you're talking about, then you'll have 50 seconds past this point. So you'll have 62 seconds. That's what is meant, up to 62. Now, the reality is that single EGID Parquet for this 2-3-7-9-7-0-1 goes to 158 plus 50. That is 208 seconds long. It is 208 seconds long. From that, we'll take a chunk, which would be 62 seconds, and then take the 50-second middle of the 62 seconds, right? So that means it will start at 6 and it will end at 56, the first chunk, and it will have a corresponding code corresponding to that of the expert consensus value for that will be other. Okay, right? Do you follow what I'm saying? And to capture what Rakil was pointing out, all you will need to do is take the fraction of the votes for these 3 rows and combine them and then convert them into a proportion. Do you follow what I'm saying? If you care about the proportion, if not, you can just make the proportion 1 for other and 0 for everything else, or you can just take the fractions of the votes that are given for these 3 rows. You do the same thing. You add 50 to 48, so you get 98, and then you take the middle 50-second chunk, and then you get the code for all these seizure group, and then you factor them, convert them to proportions. You do the same for LPD, 110 plus 50 is 160, take the middle, and you do that. Now, then you come to the other 158, add 50, 208, take the middle 50 of that, and do that accordingly. Actually, in that case, you have to be careful that you don't, when you start at 58, it's important to realize you're starting is at in each of these. I guess you also need to capture the start, because if you just capture the endpoint, as I'm talking through this, I'm just realizing that if you just capture the endpoint, then 48 plus 50 will be 98, and you don't want to get the 50-second middle of the 98. You want to get the middle of from 30 to 98.
Oh, it shouldn't be. Yeah, okay. So 30 to 90 at the middle of that is what it should be.
Yeah, that's something as I was just talking, I just realized that you shouldn't just take the middle
subtract. Yeah. Because you'll keep moving over into the other windows. Yeah, okay.
Correct. Yeah. So
you
don't want
exercise.
anything, but you need to.
Yeah.
Exactly. That's the thing I wanted to point out, that it's not a trivial pandas exercise to capture the data that you need. So that's why, by the way, I mean, you guys can also refer to it. That's why I was saying to Steve, when he said he's not ending, I was like, hey, how are you doing it? And I think his approach now.
I still didn't get this. How are you trying the next the 3 things, the next seizure one, seizure one?
What's your question?
How are you getting the next the next seizure one? How are you seizures and the LPDs and the others? So how are you getting them together into the same file?
Oh, remember that it's not, you don't get them into same file. You separate them into separate slices, which is what, see, let's stick with this example. Let's say just stick with this EGID. So one approach you could take is to say, for this single EGID, right, I'm going to take every 50-second slice starting at each of these EEG label offsets. So that would mean I'll have one slice starting at 0, ending at 50. Second slice starting at 10, ending at 60. Third slice starting at 12, ending at 62. Fourth slice, and in each of these slices, my target votes would be whatever, not the expert consensus shown here, but whatever the target set of 6 votes.
Okay.
6 classes of votes for each of these rows. That would be my target labels, right?
Okay, those classes of labels, right.
Yeah, converted to proportions, converted to probability. But for starting at 0, starting at 10, going, every slice is 50-second slice. So starting at 0, starting at 10, 12, 30, you just go down. And all of this data is in a single EEG ID. You just slice it when you're creating this, the spectrogram. You just slice the data to 50 and convert it. So if you go look at the code, then whenever they are doing, if it's spectrogram, they'll do a 300 by 400. If it is EEG, they go through the whatever the Librosa and convert it. But the point is, you're converting a 50 seconds if it is an EEG, and you're converting a 10 minutes, 600 seconds, again divided by 2, because every 2 seconds is when you get data if it is spectrogram. So going through all that math, but you get the idea, right? So that's the case.
So could you quickly take us through the code then, if that's not an issue? Because I would like to understand how the things are being done in detail, the math side of it. I have looked at that notebook, the Librosa one, which you're trying to allude to, but I'm not too sure of how much I got from it.
So let's look at, I mean, it depends. You have to kind of, I'll be switching to the spectrograms in this case.
Okay.
Not EEGs, because EEGs is when the Librosa gets used. And I can show you very quickly how it's done in this particular notebook. For example, for the spectrograms, and keep in mind that, okay, where was I? I was showing you this right now. Keep in mind that this is EEG label offset seconds. Similarly, you'll have spectrogram label offset seconds, which is what we are talking about in this example. Mm-hmm. And in this particular notebook, the thing that he does in order to simplify the generation, now keep in mind that he's not, in this notebook, he is grouping all of the EEG. He's ignoring the fact that these values change within an EEG, which is what you do whenever you group by spectrogram or by EEG.
Mm-hmm.
Do you follow that?
Yeah.
Right. The fact that expert consensus values change is ignored when you group by EEG, because when you group by, so if you take one value for this entire EEG, this particular EEG, that means that you are just saying, you're just going to group all of these rows, count up the votes, and whatever the proportions turn out to be because of this distribution, you just say that for my EEG, with this number, that's going to be the distribution. And by the way, I mean, just to, because I have the example, so I can show you easily an answer to the question you asked. I'm just switching. This is not EEG, this is spectrogram, but the principles that apply are the same. Okay. Here it's a spectrogram, and because he's grouping by spectrogram, he's just taking he's grouping by spectrogram and then simplifying this rows, all these rows, he's just taking the first one. So by that, what it means is he's just taking the very first row of whatever he sees in the spectrogram. And so the offset will always be 0.
Okay.
In this approach, okay, in this particular notebook that I followed. And then you just do, like I said, in spectrograms, he just generates the data inline. You can choose to do it offline. By inline, I mean that, you generate it in the notebook and you continue to use it. You can, much like Chris Beard does, generate it offline, put it in a file and use it. But so what he does is he reads the Parquet file, he creates empty array, flips it around because of the time and the hertz. And then depending on the offset, and like I said, as long as there is, for every offset, there's a label ID. And then he uses the label ID and the spectrogram label offset in seconds, divides it by 2, then adds the 300 is because of the spectrogram thing I said, which is 10 minutes is 600, and every 2 seconds you get a sample. That's why he takes the offset and adds the offset by 300. In this case, because of the way he has done it, every spec offset will be starting at 0. And now the this simple approach, I was able to use to generate the data for every row in the spectrogram. The reason for that is if I just didn't do this, if I didn't group, and if I just group by spectrogram ID and I did not do the head one, right, then I'll be getting a grouping of spectrogram ID similar to what I showed here. Instead of EG, it will be spectrogram, and I'll get all of these offsets. And for each of these offsets, I can find the middle, and or not even the middle. If I'm doing it for each, I don't even need to find the middle. I just need the 60 seconds starting at each of these offsets, right?
Okay.
So, for example, if I was taking EEG starting at 10, it will be 10, the spectrogram starting at 10, then it's just like for this particular spectrogram ID, I add 10 and 600. So 10 to 610, that means, because again, I'm getting every 2 seconds, so it will go from 5 to 305 will be my spectrogram corresponding to this row, and the votes will be the corresponding votes. And then in case of EEGs, it's the same thing, and you just kind of apply the same logic, except it's 50 seconds and you can work out the numbers. So that's how you create it.
Yeah, so this is from the same Chris Stewart's notebook, where he has converted EEG through spectrograms, right?
Yeah, that's not the only one. There are others, and I do it differently. I haven't played with both to figure out which is the easier or which gives better results. Let me show you the case where I use, it's similar but slightly different than what Chris does. Because Chris code is TensorFlow, whereas the approach that I'm taking is PyTorch. So, for example, like I said, I've done the per row, and it gave me worse results.
Yeah, I have to say, Keras 3 with TensorFlow is exciting. With the backends like with JAX and PyTorch and TensorFlow, it's exciting to try out those new APIs right now. There are so many errors there that pop up, but yeah, it's kind of that shoots up your adrenaline a bit.
Yeah, I haven't tried any other. I stick with PyTorch. But that I can't looking for. I generate the EG I'm somehow missing. I have my really strange because could be a notebook here where I'm actually generating the EG data. Okay. Anyway, I don't want to waste you guys' time, but there are I can post
yeah, you can
the
share that in the Slack afterwards. We can take a look at it.
But anyway, so back to the original problem that I was sharing, right? So anyway, so that vector was my challenge of figuring out
Yep.
the and taking the appropriate slice, which, by the way, I think if I let me.
So yeah, while you guys were chatting, I was kind of trying to reproduce that and then pull something. But yeah,
If you see my if you see my exchange, actually, I don't know whether I can share. Let me see whether
I don't see your screen anymore.
Yeah, no, I stopped sharing, but let me see whether I can share my screen now. That can you see my screen where I have the Slack exchange with Steve?
Yes.
Yeah.
Right. So this is where I think what he's saying, his approach now, how to do it in Pandas is still an open question, but his approach is that's what. So if you see, my question is, hey, I was giving you an example, the same example I shared with you guys of what and he's saying you can see the answer, and his answer addresses the thing that I was talking about, right? So if the expert consensus changes, then he adds a new row.
Yeah.
Right. So when he adds the row, he adds already the middle value. Right. By that I mean, like if you recall, and I forget what the original other was, let's say it was 12. So if it's 12, then he will add a new row with the offset being, you could, do the math and simply add a row with the corresponding middle point, or you can just add the middle of the rows. Right. But the important thing and the reason why adding the middle, right? This part, middle offset and only add a single row. The middle is important, right? Because it cannot, because of the reason that we were just discussing, it has to honor the starting point. Otherwise, you will confuse the thing by going all the way back to 0.
Right. Yeah. So what happens in your case when your other is the last row? That time you
that's what I was telling you. That's still a problem because you can't take a middle. You will need to add the 158 itself.
Right. So it would be 158
that's
plus
not easy
50.
Correct. And then you just take 158 plus 50 and that's it. There's no middle or anything there. You will have to go from 158 to the end. See, that's the other reason why that particular example is tricky, right? Because I don't know that the middle approach, if you always took the middle, then
but isn't that the problem description though? Like, what do they say? Like based on the offset, it's the middle 10 seconds that is being viewed by the people who are voting, right?
Correct.
So in this case where your offset is 158,
the approach, the middle of 158 plus 50.
Correct. So that should still work, right? Like I'm confused.
That should work, but if you take, but technically what you're pointing out is it's more of a problem if you think about it when you're taking the middle of a group. Because if you go in the first set of others, the first grouping of others, it goes 0, 6, 12 or whatever, let's say.
Right. Yeah.
Right. Then
You add
That
your
means you're actually taking, if you take 6 and then you take 6 to 56,
okay. The
right?
middle is different.
Then you're taking the middle 10 of just the middle of that slice. You're not technically utilizing all of the slices.
Right, right.
See
Okay.
what I'm saying? You're not
I
using the
see.
middle 10 seconds of each of the slice, which is
Yeah.
what I tried, but it failed to improve my score.
Right.
So
So that is
in
the
a
case where
sense,
you're doing each row separately, right?
correct,
Yeah.
correct,
Okay. I get what you're saying. Okay. Okay. So anytime you
right?
basically group, you're breaking the middle 10-second viewing window because obviously you're grouping, so your time frame has increased. Okay. Yeah.
Yes, but if he's taking a middle row that exists, see what I was thinking, the approach I was going to take, and again, it refines our thinking, right? The approach I was planning on taking is adding 12, let's say our last other slice, forgetting the 158, is 12,
Okay.
right? Then I was planning on taking 12 plus 50 is 62, and then take the middle of that, which means I
Right.
would be getting the middle of the last offset.
Middle of the last offset. Yeah, correct. Okay.
The middle of the mid 10 seconds
Of the last
corresponding
offset.
to
Right.
the last offset, correct?
Right.
But I'm still getting a valid middle,
Okay. Wait, why is
right?
that not
Are you with?
happening in the last one?
No, it will happen in the
Okay.
last one too.
Yeah, that's what. Okay, fine. Okay.
Now that I think about it, as long as I stick to that,
Right.
right?
Yeah.
That is, I take the 50 seconds from the max, then I'm okay, right? I don't need to do the middle that necessarily Steve is talking about.
What is Steve saying in that one? So in your example about I had 4 rows at each. What say when the what say is the same, I take the middle offset value and only add a single row. Middle offset value.
But the middle offset value is not what I need to worry about, right? Because what happens if I have like 7 rows?
Right.
Well, if I have 7 rows, I can take the middle. But what
Take
happens
the
if I have
middle.
4 rows?
Right.
What
Yeah.
is the middle? Because if
Yeah.
I take the middle of 4 rows, then I'm taking a value where the mid 10 seconds is not necessarily valid. You
The
see what I'm
mid 10
saying?
seconds. Yeah. Yeah. That mid 10 seconds probably is kind of a combination of 2 rows rather than
Exactly.
what user has actually.
Exactly.
Yeah.
But
Okay.
if I don't worry about it, and if I just go by the max and just take that, then I'm okay all the time.
Yeah, because that would be the valid for that row. Yeah. Yeah.
Correct.
Makes sense. Should I
Yeah,
go
it makes sense. Yeah, go ahead, Raquel.
No, sorry, I was just going to say like that should even hold true for if you do the first row, right? Instead of like a max, if you do a min, right?
Yeah.
Basically, yeah, if you're on any row, you should be fine. It's the problem is when you
But
kind of
yeah, the problem is that you can't just, the problem goes back. I mean, one is taking the min or the max, but my problem was the grouping alone doesn't work.
yeah, that's correct. Yeah.
That in itself is a problem.
Yep. I just shared a piece of code there. I mean, I was just trying quickly, like I just created based on your ID 213. I was just kind of simulating some data and I was seeing that was the easiest thing I could think of was like if you shift that consensus by 1, then if you check whether at each row they're equal or not equal, and that is the way I was trying to grab out.
Yeah. I mean, in fact, I can share with you guys that. Let me stop sharing and figure out whether I can show you, because I was struggling with this, and then I was, give me a sec while I share screen. Let me see where it does show that. Okay, my attempts with. Let me know when you can see my screen. It does something similar to what you were thinking about. I don't think it is shown. Now it shows up. So you can see my ChatGPT stuff, right? So that's what I was trying to do, and it kind of does something, right? Similar. So after it does the expert conversion, then it groups by previous consensus, right?
Yeah. Okay.
Previous
Yeah.
consensus
Exactly.
is shifted. Then
Yep.
it determines the switch points,
Yep.
right? And then the prior values, because what I was trying to do, my question to it was this, right? Using the same provided, what would be the kind of code to capture in a new data set the values in the row, actually, I should say, in the row prior to the value of expert consensus changing. Because remember, what we want is the max, right? So you want the value prior to it changing.
Right. Yeah.
But then but if you just do that, you will miss the last 158.
Correct.
Right? So then I said also in the new data frame, I'd like to add a new row for every row in the original, when that row in the original data frame is the last row for an EGID with a change in expert consensus value.
Yep. Yeah, I kind of did the same thing. The only thing was I gave it the example and I told you, given these rows, I want these rows out. So write the code for me.
Okay. That was going to be my final check also.
Text to type out.
Yeah.
What's the same way?
Since actually you can
Srinivasan, you should
that
try.
You can post that code and I'll try it out as well.
Yeah.
Whether that works. And now that we've talked through it, if we just take the last row, then I think
use that.
We are good with that, right? Because we just convince ourselves that each one would be a valid
entry. Yeah.
But what I don't know is whether any other cases this logic doesn't
based
work.
on that. Yeah.
Because I don't know whether, for example, you have one row of this 158, and then what happens if yet another row shows up underneath there with a different thing? Because this will just capture the last row. But suppose there isn't a last row. Suppose after the last other, there is another LPD. At least the code I have wouldn't capture that, right?
Oh, it wouldn't?
No, it might, right? Because there is a change.
Your switch point, exactly. Your switch points will grab that.
Because there is a change, it will capture it.
Exactly. So I think it should be good. In essence, it's basically that you shift everything by one row down and then you just keep checking when it breaks. I mean, it's not the same. So yeah, it should capture that.
Yeah. But anyway, this is a tricky thing that I was struggling with all last week. So I thought I would highlight it in case.
Given your exploration of that specific example shows how it breaks. Otherwise, a simple group by I thought also would work. But yeah.
Exactly.
So
I was lucky to just play around and see where, before I submitted. And in fact, the situation in my case was I thought I had done this successfully by grouping, but my scores were worse. Right? I did it for spectrogram. I didn't do it for EEG. I was like, okay, before I generate the EEG data, I want to see why my scores are worse. So I started playing around with it, literally playing around, which is why if you see that particular notebook of mine is called EEG Change Play. Because I was literally playing around with it, saying, what the heck? Why am I getting worse scores when Steve says he's getting better scores? And then I stumbled on this example of where multiple of these things change, and which also, by the way, led me to another discovery. If you go back to the code, the most common kind of code using spectrogram that does the inline slicing and stuff, then I figured out that in that code or those codes, because there are multiple of those which all get very good results on spectrogram, all of them, interestingly, right? And I shared one of that a little earlier when I was showing Mayank the example, all of those start off by taking the first slice.
Okay.
They just group and then they do a head one,
Yeah.
which means it collapses to the very first row. So you take the first row but you still do the grouping of the scores corresponding to that spectrogram or that EEG.
Group, right. Makes sense.
Are you following what I'm
Basically,
saying?
you're condensing all the result values just for that first row, right? That's what you're saying.
Correct.
Yeah.
Okay.
Yes.
Right. Now, interestingly, that in a sense, right, isn't the arguably isn't the best approach.
Yeah, for sure. Yeah.
Right. Yep. Because you could argue that you should take the middle.
Yeah. When possible.
Right? By the middle, I mean the 10 seconds, wherever that.
Correct.
But here is the interesting tidbit. I took, instead of taking the first slice, which is 0, assuming the expert consensus doesn't change, I took the middle slice for every EEG, for every spectrogram.
Okay.
Interestingly, my score got worse.
So you took the middle 10 seconds of which
not
one?
The middle 10, not the middle 10, but the middle 50 of every
row.
Sorry, no, because we're switching between spectrograms and EEG. I just did it for spectrograms. I took the middle 10 minutes of every spectrogram.
Okay.
Parquet file.
Okay.
Right? Instead of the starting 10 minutes. I took the middle 10 minutes.
The middle 10 minutes instead of the starting. Okay.
So, for example, if we were to take the very first spectrogram ID that shows up in our notebook, training CSV, that has an offset of spectrogram offset and EEG offset are the same, but the max offset is 40.
Okay.
Okay. So that means it will go from, for a spectrogram, it will go from 0 to 640. Right? Now, all the reference notebooks that I had were originally using 0 to 600 or 0 to 300. I mean, just to be consistent, it's 0 to 300 because every 2 seconds is when the sample is taken. So it's 0 to 300. So instead of taking 0 to 300 for the first example, I would, if I were taking the middle, go from 10 to 310.
Okay. Yeah. Okay.
Because the max offset is 40, which divided by 2 will be 20, and then you split the difference 10 on each side. So you go from 10 to 310. Are you following?
Yeah.
Right. So if in that example, instead of using 0 to 300, which is what the original notebooks did, I took 10 to 310 and my scores got worse. Now, the explanation, the rationalization I have for that is the following, that if you take the first slice, right, you generally, if you get a first slice, you're starting off with a particular fixed value for your expert consensus, correct? The expert consensus changes as time goes on, not initially, right? So if I take a middle chunk, then in cases where the expert consensus changes, I'm giving it more of a confusing data.
I see. Okay. Because of that shift in overlap, because because each row, as you go down, the expert consensus has this change.
So I'm showing it something which is inconsistent and giving it the labels which are, the labels are always the same, right? Because the labels have been collapsed.
Yeah.
Right. but I'm showing it more of a confusing data when I take
The
middle chunk.
Right. Okay.
Right. So that it gives credence to Steve's approach that if you actually are careful when it changes to give it the data and limit it to the data when it doesn't, when it's consistent, then your model ought to improve. Because my results where when I take the middle, it worsens, to me is more of a proof of the correctness of Steve's approach as I see it. Because the more data you add from the latter things, which is what I do when I shift the middle. So, in some cases, then I'm confusing the model more.
Yeah. Yeah, you're confusing the model more. Yes, correct. Because the labels haven't changed. Yeah, in that sense. Yes.
Yes.
Correct. Okay.
So at least that's my explanation for why I see worse, because I was expecting better results.
Yeah.
But I see, and then I started to think about it. So it's kind of interesting, like, that's why I think the approach Steve is taking is a smart one too, that you kind of try to take the cases clearly, because again, keep in mind that in the test situation, you just show it a single EEG and a single spectrogram. So there's none of this confusion thing.
Right.
So when you train it, it's better if you also adhere to that. And that's what you're doing by making sure that whenever it flips, even within an EEG or within a spectrogram, you give it a better underlying data corresponding to the labels.
Right. Okay. Yeah, need to. I haven't got a chance to run anything, but yeah, this week I think I should have time. So yeah, this is
interesting. But anyway, I can share one other. Obviously, I finally managed to also move all the data to always a brain to Colab. Started to do so that I can get a little more run. Let's see whether I need to sharing already or no?
No.
CBS to oh, I see. But I, the one thing I was able to do was a large number of. Let me know when you can.
I can see an Excel sheet, but I think it's still loading. Yeah.
I mean, these are all the various runs that I have. But so you can. So the thing I was telling you, right, is the let's see, ResNet 34B. So this is when I took, where I the last row,
Hmm.
34D mid baseline,
Hmm.
it shows a score of 0.51. That's only based on spectrograms,
Okay.
but based on the middle,
Hmm.
the one that I just described here, taking the middle for each spectrogram. Okay. Now, correspondingly, if you look at my okay, so if you look at here, you look at this row,
Hmm.
the same thing, but taking the first slice.
Oh, I see. Okay. Okay.
You see
Okay.
the score as worsened.
Hmm.
Right? And B here to me means which slice I've taken. So this is the beginning slice, this is the center slice.
I see. Okay.
Everything else remaining the same. You see the beginning slice is
Hmm.
of course better than the end slice. Center slice.
Center slice. Yeah, I wonder what will happen with the end slice. So according to your explanation, that should be worse, right? Because the result doesn't change. So the consensus is still weighted more on the beginning.
It depends on how much of the
10 seconds
the
lies within.
consensus changes happen later. Yeah.
Right. Yeah.
Yeah. It'll probably be still worse than the beginning slice would be my guess.
Hmm.
But
Yeah.
but for sure it says, now in EEGs on the other hand, it's always the middle slice that's taken.
Hmm.
So they took the correct middle slice. Is what is the case. I haven't tried it with with the EEGs, with taking the beginning slice and see whether you get a better score than what. Because I was working on this. Let's get corresponding, what did I call it here? Bit of, and you can see also the all thing that I did here. All is actually even worse than the middle slice. Because you see the middle slice is 0.51, the all slice is 0.52. And I'm calling this approach of taking whenever the thing changes as dupes, just some name for duplicates. That is, for every EGID, I have duplicate slices, right? Depending on when I've been maxing out all my Kaggle resources. Bunch of experiments.
Yeah.
But so, I mean, obviously people have gotten to 0.3637, but mainly those have all been ensembles and
there was a 0.28 I was seeing. So
the leaderboard, is at 0.28, but I'm saying any public notebooks are all at unless they've changed over the last day or so, have all been at about 0.3738 and stuff. So which is where at least that's why I started shifting to Steve's approach, because none of them seem to take that. And if you're getting a better score, then you can get a better score on the underlying spectrogram and EEG, and then when you combine them by any of these ensembling approaches, you're going to obviously get a better result.
Right.
But another interesting tidbit that I saw, which is kind of I observed myself, is many of these spectrograms, like I said, they are variations of the books that are being published that I took and modified and stuff. And, some of these were, for example, this one, wherever it says SKR, blah, 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 that uses the stratified group fold, 5-fold or 10-fold or whatever. And where it just says baseline, like this, then that does not group, nor does it stratify. Because grouping is grouping by patient and stratification is stratification by expert consensus.
Okay.
Making sure that each of the folds has a distribution of expert consensus. But strangely enough, if you don't care about that, interestingly, sometimes you get better results.
Oh, okay. Is it significantly better or it could be just?
Yeah, in some cases, at least by a couple of points.
Oh, okay.
I mean, not a couple of hundreds of points. Like, for example, so let me see whether I can. Oh, okay. So if you let's compare the same architecture, but grouping and not grouping, right? Like, so if you see this score on spectrogram, it's 0.48, right? So this guy groups and stratifies. Or this guy meaning, my version of the notebook, it groups and stratifies. Okay. The same thing here, right? Remember, this is ENet B1, and this is also ENet B1. Okay. Now, this ENet B1 uses, I think it is particular type of learning rate. I think it is that also is different, by the way. That's why I put this BS cost. The batch size in this case is 16, and it's a cosine learning rate, and there's no stratification or no grouping. That gives me 0.44 on ENet B1.
5 folds there, right? What are the 5 folds? If there must be some grouping then, right?
Oh, no. The grouping is different, right? The grouping is grouping by patient ID. The folding, you do 5 folds anyway. You just fold.
Okay.
You select 5 folds, but grouping and stratification are grouping in the test and the train by patient ID. So make sure that the patient ID for a particular patient doesn't show up in validation if it's in train. And you don't do that in this case.
Okay.
You say, I don't care. Because, I mean, you can argue whether you should care about it or not, right? Like, there's no, I can't think of a good reason to.
It's like there is data leakage in that case. So
it's not a given that you should not cross that boundary. At least I could argue the case where it shouldn't matter. So by grouping, I mean that grouping, that by patient ID. That's what I mean. And in this case, I don't group by patient ID. So my same patient can show up in train and in my validation. Okay. And my batch size is lower and I'm using a cosine learning rate scheduler. Here I'm using something but slightly different learning rate scheduler. In both cases, I am using a learning rate scheduler. But you can see that my scores are different by about 400ths of a point.
Yeah. Yeah.
Right? And it's not just, see, even in this so B1 and B, I ran it both ways. In fact, I ran it for all. So you can see this is 0.47, this is 0.45, this is 0.48, this is 0.44.
Hmm.
The ResNet also 0.48. Here, 0.47. Here it seems to make less of a difference. But for EfficientNet, it makes a big difference. Again, can't explain why that is the case.
Hmm.
Again, all for spectrograms. I don't know that I've done the same thing. But again, I wanted to kind of have all of the data so I can kind of focus on the basic building blocks which give me the best results and then ensemble them, right?
Yeah, that makes sense. Yeah.
The ensembling part is easy. Once you get the base scores better, that's matter when you put it together. Anyway, I was getting so confused with so many of these runs. I thought I'd prepare a table where I have all of this so I can see what I did. Notice trends like what I just talked. Anyway, that's what I've been up to. But like you said, then I think, but my test case I stumbled on toward the end. So I will, actually, I'll try your code. So you gave it the exact code for that particular EGID and said, give me these rows, and that's what it came up with.
No, I've just created something with just categorical variables like A, B, B, A, C, and then like some time variable, and then I didn't have that handy right now, so I just created something like that. And then gave it the first row of each of those things, and then said that kind of give me the groups based on how consecutive they are. But all in all, I think yours and I kind of pointing in the same direction. So that should work. But I'm curious. I have some time this week, so I'll take a stab at it and see if I can move up the leaderboard. Last 2 weeks were kind of busy, but
no, I haven't submitted anything. So I'm like, I've sunk.
Experimenting.
Because, as I said, I was focused on getting the base thing to be better and then building, because you can always keep submitting the ensembling thingies.
Yeah.
I felt working on the base stuff is probably worthwhile.
Yep.
I haven't, the other thing which we had some questions or discussion, I wanted to get to it this week. Unfortunately, I didn't, is what the guy tried with all these fancy, he uses an RNN.
Correct. I saw your discussion on that, and that notebook looks like extra confusing. There's so many.
It has a bunch of custom networks and shapes and reshapes that going.
Look at what Steve was using. That same guy is 1D CNN. Maybe first go through that part and then understand, and then kind of that's what my idea is.
But the thing in it that I like, and there are things which I kind of am like, why, or I don't get it, is the thing I like is he combines a third flavor into the same thing, which I haven't seen anybody else do. A third flavor, I mean, most people are using EEG and spectrograms, right? But what he does is he combines the raw EEG as well. That's, I think, something I like, because it brings in yet another type of data, if you will. That said, I'm not convinced why you have to make all these, you could potentially just use standard architecture and then just combine the third piece into it. The third piece, by third piece, I mean the third type of data. I don't quite get the need for custom network.
Yeah, I don't know,
and
because I think he has a contrastive loss somewhere in there, right? So
yeah, and the contrastive loss, that's the part I haven't delved into. At least of what he is exploring the contrastive loss of, whether which two pieces is he contrasting. I mean, in the diagram, and then actually confirm with the code, because as I showed, and I was puzzled by a piece of the code where I thought he was combining spectrograms and EEG, and then it turns out that he isn't. So I was like, are you or are you not?
Not being used in that piece, yeah. I was also not sure what was going on there.
Yeah, so I have to trace through that.
Yeah, and that notebook doesn't run straight out of the block, right? You need to make.
Oh yeah, you have to kind of create, and that's why I was saying, I mean, before I did all the work to get it running, I really wanted to understand it so that if possible, then I can do my own thing with the data rather than just necessarily follow exactly everything that he's doing.
Right. So after those questions, I thought it would be probably better first kind of look through the 1D stuff.
Yeah, which is what Steve was, I think, working on. And he said that, and the difference between the 1D and the 2D in the discussion, it came up is in 1D, it seems he doesn't, while he has a bunch of cleanup of the EG, he actually ends up not using it. But in the 2D notebooks that I saw, he was actually using a bunch of stuff, including kind of augmentation of mix-up augmentation and other kinds of things that he's not using. But, on the other hand, the frustrating thing, if you think about it, is at the end of combining all three data types and stuff, he ends up at like 0.41.
Yeah,
right? Which many people have achieved with just a combination of two data types.
Yeah, I don't know,
like 5.
Just if that's just like a baseline submission where there are things that we can kind of improve from there. But I'm just curious about the way of mixing these data.
But
that's what is.
Yeah, that's why I said that's interesting. But at the same time, I mean, other than maybe changing the underlying data like we are talking about now, which is to improve the
which is part of the data sets to use.
There isn't much else that you can do, right? I mean, well, you can improve the architecture, but again, it's a very custom thing that you're using as the architecture. So, to know what knobs you will turn and whether it gets worse or better. Which is why I wanted to understand his notebook, to maybe take then more of a building block standardized approach, which means that I'm just processing the stuff using standard network rather than custom architecture, and then it's just then I can twiddle the knobs that go into the model easier. I guess that's at least was my thinking. But that's why I wanted to understand his notebook first, so that I can modularize it, if you will, and then vary the inputs and the knobs to the modules.
Yep.
Okie dokie.
Alrighty. Talk to you next week then.
Yep. Talk to you then. Yeah.
All right.
Bye.
See you.